Okay, so today is class one of analytic geometry. So mostly in this class, we will come across how 2D shape, three-dimensional shapes will look in. Okay, so this is a three-dimensional shape. Okay, you have your x, y, and z. Okay, so x, y, and z. But we will look at these at a two-dimensional line. Okay, so this could be a three-dimensional thing. Okay, this could be a three-dimensional. We're going to cut them in two dimensions. So we're going to look them at how they will look in segments. Okay, so that is one part of analytical geometry, and this will be the first chapter that you will have two variables, and both of them will actually contribute to the shape of the graph. Before this, usually we always have everything y in terms of x. Now you will start to see y plus constant squared plus x plus another constant squared equals to, you'll see something in these terms. Okay, so there'll be some standard forms you will start learning on this chapter. Okay, so as mentioned before, all of this, we'll try to wrap up this class by this week as if we can. If not, let's see where it goes. Okay, so I think that's enough introductions. Let's go with question one. So question one. Okay. Wait, before we go to question one, how about we do some, let's go through some notes first. Okay.
Okay.
All right, one moment. These posted these on the Google Classroom. So yeah, just briefly go through what I posted. Now, there's four things you'll learn in this chapter. One is parabola, the shape and how the functions of a parabola look like. I think this is the most familiar to everyone because this is basically a quadratic equation. Okay, so then we'll go to ellipse. Ellipse will be
I can.
the yes, anything?
Oh, okay.
Okay.
No, just now I couldn't see the screen.
Okay, my bad. All right. Okay, so we'll learn secondly about ellipses. So ellipses, this is where you first start to see this y squared notation. And also you'll see these type of graphs where you'll see fully closed off shapes. Before this, we will have never seen closed off shape in math before. Usually it's a continuous function and goes from one point to another, or it's a closed composite function. But this is the first time you'll start seeing these closed functions like this. It's a circular function. Okay. And after ellipses, you actually see there's a special ellipse, what we call a special ellipse is basically a circle. The circle is when you have an ellipse that has the same value for the radius in y and x directions. Okay, on both axes, when it's equal to each other, that's when you have a circle. So circles are what we call special ellipses. So after that, we have our hyperbola. Hyperbolas will be the opposite, I would say, of an ellipse, where when these two are branched into each other and have a closed system, you have hyperbolas where they both reach to two ends of infinity. And this will be one of the harder ones to learn, and it will be the last one that we will go through. But don't worry, hopefully we can go through this on time. So all of these, if you can notice in the notes, the most important things are the circle, vertices, for side, the length, okay, and the asymptotes. The asymptotes you will only notice in hyperbolas. You will not see asymptotes in ellipses, nor will you see asymptotes in parabolas. Okay, and for parabolas, you'll see vertices, directrix, and focus. For ellipses, you will see center, vertices, and foci. And the length of the major and minor arcs, you will not see some terms will only appear and they were actually hints on what the shape of the graph can be. So if they ask for an asymptote, you can be very sure that it's not most likely, it is a hyperbola. Okay, for this chapter, just for this chapter alone. And also you have these things, what we call parametric equations. Okay, these are some extra notes where you can have these things in terms of trigonometric functions. Okay, I will go through later why we have these trigonometric functions later. Okay, so those are the notes. Okay, okay, now back to our class. All right, so we're going through the notes. Okay, so for this question, okay, let's start with a simple one. We'll go to from easy to hard. Okay, so question number 3. Okay, find the equation of the following parabolas. Okay, they already mentioned parabola and sketch the parabola. Okay, so actually sketching is one of the easier things in this chapter. Okay, I found a new color today. I would like to try using this color. Okay, it's a rainbow color or space color. Okay, looks like this. Quite nice. All right. Find the equation of following parabolas and sketch the parabolas. A, directrix of the line is negative 3 x equals negative 3, and directrix of line y equals to y equals 5. The vertices are on 0, 0, and also 1 and 2. Okay, let's just go through this question quite easily. Okay, so how will this look like? Okay, for A, okay, so when they say directrix is x equals to negative 3, what this actually means is that the directrix or the axis of symmetry, okay, how about I just write this as AOS, okay, dissociation of space, AOS, okay, axis of symmetry. So for now, I can use AOS to just make axis of symmetry. Is horizontal, is horizontal, okay, is horizontal. So and also if you notice, it's 93. Okay, so that means that the directrix is the on on the left. Okay, on the okay. So your directrix is on the left and is horizontal. Okay, so the equation most likely will look something like this. It will be y squared equals to 4p. Okay, it looks something like this. Okay, p is just any constant. It can be anything, but since they never mention anything, so you can actually say that the modulus of p, okay, will be equal to the distance, okay, the distance from the directrix to the vertices, okay, the directrix to the vertices, okay. So and we can say just that p equals to 3. Okay, since we know that the vertices is at 0, okay, so the vertices is here is at 0, and we know the directrix of the line is at negative 3. I should draw this somewhere better, just like this. So we know the vertices are at 0. We know that the directrix is at negative 3. So usually it's double, okay? So if it's this much, it should be also this much. It should be also at 3. So that's where the point will be at. Oh, wait, I made a mistake. Okay, so we know the distance is negative 3, so we know it's just 3, okay? P equals to 3, so just 3 off. So the graph will look something like this. Okay, I'll change the color to make it more noticeable. I'll use rainbow. Yeah, okay, looks nice. Okay, so the best thing about this, in these type of questions, the less information they give you, the less you have to provide. Since it's only they mention that the vertex is 0, 0 at origin, and also that the directrix is that line x equals to -3, and that's all you need to input. So everything else about the curvature and everything else is just a sketch. Okay, the main word here is sketch. In SCVM, I think I mentioned this in a previous class. They will not ask you to. They will only ask you to sketch. Okay, so that's question one. Quite easy of a question. Let's go to question B. Okay. Question B. Okay. So question B, it says that y equals to, let me see that again, y equals to 5. Okay, y equals to 5, 1, 1, and 2. Okay, okay, y equals to 5, and it's 1 and okay. So since you know y equals to 5, we can say that the axis of symmetry is vertical. Okay, or is vertical. And since it says that it's 1 and 2, okay, 2 is below 5. 2 is below 5. Okay, the y value here, x value here, 2 is below 5. So you can say that the directrix uh, is below. So when you start graphing, look something like this. Okay, so and we know, okay, so the same logic applies for this also. Since we know it's below, we know that p is most likely less than 0, or it's p, you can say, is a negative value. Okay, so when p is a negative value, say, and it's just 5 minus 2, which is -3. Okay, so and we have the center part, and also the vertex is on 1 and 2, like here. So it's something you can say this is 0. So 1 and 2, okay, let's label this as 1, maybe let's label this as 2. So this will be the vertices. Okay, okay, maybe I need to extend the line. Extend the line over here. Okay, so this will be maybe 5. Okay, so how will this look like? Okay, so for this, you can just same like logic before, since it's p is negative, you can make the graph as x minus 1. Okay, if it's positive, remember it's just a flip, it's always flip. So x minus x, if the coordinate of the vertices is 1, you just put -1. Okay, and you square equals to, okay, -12 and y minus, okay, y -12. Okay, I just made it like this, 4 times by -3. So I just really put in the curve. Okay, so how will this graph look like? Okay, the graph will look something like this. It will be, okay, it will look something like this. Okay, and don't forget to label your directrix. Okay, just put a like simple, just put like dotted lines. You don't have even put a straight line. And if possible, just put X on your vertices. Okay, for this one, I would say it's okay to not label these. It's okay to not label these, but you can still do it. Okay, you can still do it. Okay, so since this is a quadratic equation, mm, yeah, quadratic equation. So you can just find these points quite easily since x minus 1 squared times 12. Okay, let's try to solve this out using different variable. So x minus 1 squared equals to, okay, 12. Okay, y is 0 at these roots, right? So I would say this is equal to 0. So -12 times 1 times by -2, that's 24. Okay, and square root of 24. Can you check that quickly on your calculator? How much is the square root of 24? I think it's 6 and 4, 8. So square root of 24. Let's just check on the calculators. Okay, should be 236. Okay, should be 236. Okay, plus minus. Wait, take this away. Okay, this is minus 1. Okay, minus 1 equals to positive, negative 236. And x, so that means x will equal to uh, 236 plus 1 or equal to 1 minus 236. Either one. So since we are positive is most likely going to be here. Okay, so this I can say 1 plus 266. You can give this in decimal also up to you, but I'll just leave it like this. Third form looks nicer and neater. And this will be 1 minus 266. Okay, and you can also find this point also. This point will be when x equals to 0, right? So when x equals to 0, then just negative 1 square. So that's 1 equals to negative 12 y minus 2. So that's just over there, and this says y equals to negative 1 over 12 plus 2. I think that's equal to 40, 48, 46, 46 over 12. 46 over 12 is basically, how much is 46 over 12? 23 over 6. 26, 23 over 6, yeah. 23 over 6. So this point will be 23 over 6. Okay. Okay. So looks like an easy question, but sometimes they can be hard to. Okay. Yeah, do I do everything right? Yeah, looks like it. Okay. So this is the first time, this is parabolas, okay? Parabolas, I would say, is the easiest ones to calculate because either one will be linear. Either if is linear, then y is poly. If is linear, then x is polynomial. So it will never both both won't have powers. Okay, that makes life easier. Okay, but when we go to ellipses and hyperbolas, that's when I would say it becomes. All right. So let's go to question number 4. Would you like to try question number 4? Maybe we can give you a chance to try this out. Okay, maybe take like, okay, since we took so around, I know 10 minutes, maybe you can have like maybe 6 minutes. Okay, it will just me explaining for the most of the time, right? Okay, like 6 minutes, maybe 3 minutes for here and 3 minutes for here. Okay, have a go.
Okay.
All right. Okay, so let's come back to the question. Okay, I changed my marker. I really like this space marker, really nice. Okay, so find the equation of both parabola and sketch the parabolas. So the important part here is find the equation. Okay, so let's go to A. So then we know the focus. Right? Our focus is F is at 1, 3, and the vertices is at 1, 5. Okay, so what can we do with this information? Okay, first you have to remember that, okay, so in vertices is here. Okay, let's draw an imaginary line. Okay, let's just draw a line here. Yes. Okay. So for this part, look here. If you notice that the x coordinate is the same. Okay, x coordinate equals to 1 for both. So it means that it's most likely it's opening upward. Okay, so either opening up or downward, not side to side. Okay, now side to side. Okay, right. So that's the first thing we can notice. And next part is the vertices is above the focus. Okay, so this will be the vertices around here, 5, and this will be the focus, around 1. Okay, so we can say that the axis of symmetry is vertical, and we can say the parabola opens downward. Okay, why can we downward? Because P, when you notice that the focus, because the focus is below here, which most likely is going to open downward. Okay, so wait, before we continue, just want to double check. Okay, so this is the important parts of the of a parabola when it comes to this topic. Okay, so you have this graph. Then okay, maybe I can draw it a bit better. So we have this. Okay, so there's three things you can remember. Okay, so this is your what you call the directrix. Okay, the directrix. Okay, directrix is usually a line. Okay, it's always a line equation. So it's either x equals to some kind of constant or it's a y equals to some kind of constant. Okay, it's always like that. Okay, and the focus is where you can see that the distance from the distance from the focus to the line and distance from the line to the directrix will be equal. Okay, maybe I did a bad job at drawing this. Maybe I can. Okay, it'll be always equal. Okay, these things will always be equal. Okay, for both sides. I can just imagine it like that. All right. So these things always spread outward at the same amount. Okay, that's what you can think of. So you can think of it also like this also. So when it comes from directrix to vertex and vertex to focus, it's the same amount. Okay, the same amount. Okay, same. So should be the same amount. Unless I'm wrong. Okay, okay. Okay, so how do you go about solving this question? Okay. So first part we can take here is the same. Okay, we have the vertices, right? So we can do the general formula. So general formula is always this. Okay. It's either when if it's a downward and upward, I think you can always know that it's going to be uh what x. Okay, if it's a bit the ballet from what we do with normal quadratic equations. If it's downward or upward, we know that x there's two, right? If we intersect twice. So just remember that x is squared. Okay, for x and okay, y now we say y minus 1. Okay, we want it to start at 0. We want this point to be our origin point. So if we want that to be our origin point, whatever offset we have from actual origin itself. Okay, this is actual origin, right? Let's say here's 0, and here's like, I don't know, -1, maybe 3. So we want to know that is offset. Okay, that would be the new offset. So we want to add 3 for the y and also add 1 for the. Okay, we do this. So for this question, since the vertices is 1 and 5, so we want to minus 1 and minus 5. So the equation looks something like this, right? It will look like x minus 1 squared equals to 4. 4 is a constant. The 4 is always there in this equation, okay? T and y minus 5. This is how it looks like. Generally, this is how the equation will look. Okay, so from this, what else can we do? Okay, since we know that the vertices is here, the focus is here, and this is the focus, this is the vertices and traits. Okay, we can say for sure that the P is negative. Okay, the P is negative. Or we can say it's less than 0. Okay, so just like the directrix and vertices, the directrix and vertices, just like I mentioned, the distance from directrix to vertex and vertex to for side is same. It's the same. So you can just remember this generally. B minus B equals to v minus f. Or you can say that the distance from b to f is equal to any of these times 2. So I can either say do dv, or you can say it's 2vf. Okay, okay, it's the same distance. Okay, so since we know that here is 3 and here is 5, so that's going to be a negative 2. So I can say with confidence that if p is negative 2, so we can add up to this equation. We can say x minus 1 squared equals to 4 negative 2 y, sorry, bracket, minus 5. And we can just multiply these. Sometimes I prefer not to multiply. It doesn't matter really. But you can multiply it and make it a negative 8. But I prefer to leave it like that because I think it's neater. Okay. Okay. Do I have a lot of space here? Okay. I'll reserve the space for B. I'll erase this for now. Okay, use that. So okay, I hope you are jotting this all down, but if you're not, don't worry. This class is recorded. Okay. Okay, let's sketch our lights. Okay. So now we know that it goes downward. The vertices is at what the vertices at 1, 5. So I can say this is 1. Maybe this can be 5 for me. And I know that the focus is around, I don't know, 3. So the focus is here. Please label the focus, put an X on it, put a dot on it, no problem. And then just come down. Okay, since we know it goes down, negative mean it goes down. Oh, okay, it goes down. Except this line here. So it will be X, this will be our Y. Okay, this will be our point or vertices. You can also label the directrix if you want. So since we know this is 2, so directrix will be around 7. So 7 here. This will be the directrix. Okay, and same like before, since it's a quadratic equation, maybe you can solve for the roots. Quickly just put on your calculator when y equals to 0, and also find the y-intercept. Since you get that one, you can try now. Okay, take a minute or two. Okay, so 8. Oh, is it? Sorry, this is not a plus. This is a minus. Okay, so that's 8 minus 1 over 5. Oh, okay. 5 minus 1 over 8. So 39 over 8, is that correct?
34.8.
Okay, so the answer here is 39 over 8. Thank you so much. 39 over 8. Okay, so this is A. Okay, this is A. Okay, how about we try, how about you try B? Maybe take like 2 minutes to try, 2 or 3 minutes to try B since you know the steps already. And let's replay again. Okay, let's dissect this question. So, okay, let's get 1, 3, negative 1, 3. So 1, 3, negative 1, 3. Okay, so, oh, no, I want the colorful space. Yes, thank you. Okay, 1, 3, negative 1, 3. Okay, what's changing here? X coordinates, not the Y. Not the Y. Okay, X is changing. So that means that most likely it is opening left and right. Okay, opening left and right. Okay, so let's see where the focus is. The focus is on the right side over here, and the vertices is over here. Okay, so it's opening to the right. Okay, let's look at it's 1 and negative 1. So vertices is here, focus is here. Okay, it's opening to the right. Okay, so we can plug out the general equation. So that's y minus, okay, we know the vertices. So it's a minus, so it's a plus. Oh, sorry. Yeah, minus is a plus. Oh, wait, it's y. Okay. Positive number becomes a negative number. Y minus 3 squared equals to 4 t x plus 1. Okay, this is the general equation. Okay, so what we do here, find p. So what's the difference here? From the focus to vertex, it's negative 1 and 1. Someone slept today. Okay, Tharani is finally here. Okay, good morning, Tharani. Glad you can make it to class even though it's a bit late. We are
Sorry.
it's okay, no problem. Okay, we are on question 4 actually. We're going a bit slow today. Okay, all right. So we are on question 4. So this is the question. Just snap a picture first, and I'll tell you where we are.
Normally, when Sharvina is absent, you always PM her, but you never PM me.
And I think I left the message. I
No.
did it. Oh wow! I sent the message and then I forgot to hit send. I forgot to hit send. Enter. I know. Sorry. I sent the message. It's just there. My goodness. Okay.
Oh, okay.
I forgot to hit enter. I'm like, okay. Okay. Never mind. We're going to question 4 right now. You didn't miss much, lah. Okay. Okay, so focus and vertex. So that's the information we are given. So from there we can find P. So since we know that the vertex is behind the focus, it's most likely opening. What? Okay, opening like what? And then for P is just you just minus these 2 points. Okay, so we know since opening output here to the positive side. Okay, remember graph. This is positive. This is negative. Okay, so it's opening the positive side, so it's going to be a positive P. This is 2. So equals to 4, 2 x plus 1 minus 3. Right. Okay. So this is how our general equation will look like. Okay, if you got this, okay, that's good. But after that, okay, so sketching the graph. Okay, so sketching the graph, how will that look like? Okay, since we know the vertex is somewhere here. Okay, somewhere here, negative 1, right? And the focus is somewhere here, 1. Okay, and so we can, okay, so how much is this? Y. Y is like 1 and 3. Negative 1 and 3. So it's somewhere here. Okay, let's say this is 3. This 3. Okay, somewhere here. Okay, now I don't know whether it will go across this. Will it pass here? Or will it go through here? I don't know yet. So for this type, I would recommend better you find the y-intercept. Okay, how to find the y-intercept? Y-intercept is when x equals to 0. Okay, when x equals to 0. So x equals 0, you get 4 times 2 times 1, that's basically 8. So square root of 8 is y minus 3 equals to square root of 8. So that's 2 set 2. Okay, positive negative. That's y equals to 3 plus minus 2 set. Okay, so I'm pretty sure this will be the. Okay, let me just extend the graph. Okay, maybe here. I use a different color. I use the yellow like before. Okay, so this will be 3 plus 2 set 2. And I think 3 minus 2 set 2. Is that a positive value? Is that a negative value? Can you someone quickly check on your calculator? 3 minus 2 set 2.
0.17.
Positive.
Okay, positive number. Lah. Okay, 0.17. So it should be around here. Somewhere here. Okay. Since it's sketching, you don't have to bother if it's very accurate or not. If it looks good enough, it's good enough. Okay, 3 minus 2 7. Okay. And then here is okay. Where will we intercept? Okay, find the x-intercept. Well, how do you find x-intercept? When y equals to 0. Okay, y equals to 0 is negative 3 squared is 9. That's going to be 9 equals to 4 times 2, 8 x plus 1. So how will it look like? X minus 3 is 9 squared. So go over here. So that 9 over 8 equals to x plus 1. Yeah, x equals to 1 over 8. So 1 over 8 is around here. Okay. How about for the sake of being chunty, I'll make this 1 over 8, I'll make this 1. Sketching 1, doesn't matter. Okay, so I'll use the rainbow for this. That's only okay, done. And this one also. Oh, uh, yeah, something like this. Okay, so make sure you pass this spot, and this spot. Okay, you can also add the directrix since you know the distance is 2, so it's most likely negative 1. So if it's here, it'll be negative 3. So that will be the directrix. So, and if you say the directrix is x equals to negative 3. Or, okay, so this is the sketching part of question. Okay, so far we only done 2 questions, but that's because sketching is quite boring. Okay, so this question, let me see. This is the function, state the domain and range. Okay, maybe I can skip this one. You guys can try it later when I post this thing, but I'll skip it for now. Sketch each of the following graphs. Okay, I'm going to skip some of the sketchings on this class because I'm also trying a bit Rashi. Parabola. Okay, I mean we can do this since this is a very straightforward question. Okay, find the axis of symmetry with this vertex, focus, and directrix. Okay, since from this question alone you can know what are they asking for. Okay, you already stated it's a parabola. Okay, that makes your life easier. Why is it so thick? Okay, parabola. Okay, so how will you go about this? Complete the square. So since it's y squared, so if it's y squared, most likely it's a okay. Look at inside. Positive square. Okay, you won't know yet, but we can do solve this one. Okay, just complete the square. Okay, y squared minus 2y minus 2y is what? Most likely positive 1. If you add positive 1, you have to minus minus 1 minus 2x plus equal to 0. Okay, so this will give me y minus 1 squared. And this negative 1 will go here, become positive 9. So all the way here will become 2x negative 9. Okay, then from here on, you have to make it such that take away this 2. You take away this 2. Okay, you have to make it x here only. So here is x, so that will be x over 2 and 2. And this is my own personal taste. I mean, this is my preference. Okay, I prefer to have it like this. I like this for here for this equation because I mentioned before. The general equation for parabola is always y minus a squared equals to 4p vector x minus b, something like this. Get it in general equation. If the other way around is x minus a squared equals to 4p y minus b. Okay, either one of these. So I prefer having this y out. If I have this y out means I have to factor out y from these two. So it means 1 over 2. Okay, so 1 over and x minus 9 over 2. Okay, so y minus 1, 4, 1 over 2 x minus 9 over 2. Okay, I think that is complete. Okay, so what can we do with this information? Okay, so this is P. This is P, you know, with P. This is our sorry, this is our vertices. Wait, maybe I should change the color. Rainbow time, okay. Oh, space is better. Space. Okay. We take this, take this, take this. These are the three important bits of information. Okay. Since we know it's a positive value and it's in y, it's most likely y is squared, so it's most likely opening to the right. Okay. And we know that the vertex is what's the vertex? Vertex. The vertex is -1 and 9 over 2. Okay, so v is okay. Since both are negative, we take positive side. Okay, 9 over 2 and 1. Okay, we know what is p. So from the p, it's just plus minus. If you plus the p into this coordinate, okay, since we said that it's opening to the right, that means the directrix is here, the focus is here. Okay, you plus p into the x coordinate, you will get the focus. You minus p, you will get the directrix. Okay, so directrix will be, okay, if you minus p, okay, this is a 9 over 2, right? So 9 over 2 minus 1 over 2, how much is it? 4. Okay, so directrix is x equals to 4. Okay, how about the focus? Focus is when you plus the p into the vertex. So it's 9 over 2 plus 1 over 2. So the focus is at 5. 5, 1. Doesn't look clear. 5, 1. Okay. And what do they ask? Axis of symmetry, vertex, focus, and okay. So we have the vertex, we have the directrix, we have the focus. Okay. Axis of symmetry is basically here, already given. So I'm getting, one moment, I'm so sorry. I think it's the important call. Okay, I'm so sorry. That was not an important call, that was a scan call. So my apologies. Okay. So we know there's 5 over 1 and axis of symmetry. Okay. Since we know all of these are in 1, okay, we can, for sure, we can say the axis of symmetry is basically y equals to 1. Okay, y equals to 1. So just for the heck of it, let's draw this. So it looks something like this. So we know it's 5 and 1, 9 over 2 and 1, right? 9 over 2 and 1. So I know 9 over 2 it should be like this. Can say this is a 9 over 2. This is 1. Okay, so we know that the directrix is left. So here, directrix is 4, focus is 5. Then here, and here. And the axis of symmetry is when y equals to 1. And you then, if they didn't ask to sketch, don't sketch. You don't waste your time. You never have enough time. Okay. But yeah, it will be gonna look like this. Okay. So that will be the question. Okay, next. Okay, how about you guys try question B? Question B is x squared minus 4x plus 8y minus 2 equals to 0. Okay, have a try with this question. I'll give you guys maybe 3 minutes. Try this out. Don't need to sketch. Just give me the information. That should be enough. Okay, I think we can just continue with question B. Since we don't want to waste a lot of time. Okay, x squared for x plus y minus 2. Okay, x squared for y negative 2. Okay. So correct. Plus minus arrow. Plus minus. Oh, okay. So same like before, complete the square. So we're going to complete the square. Is 4 is most likely 2. So 2 squared is also 4. So for x plus 4 minus 4 plus 8y equal minus 2 equal to 0. Theta is x squared, right? X plus 2 squared. Minus minus 4 minus 2, that's minus 6. So it equals to 8y minus 6. 8, 8y minus plus 6. So this one we have to remember, like I mentioned just now, you have to take this y out. So negative 8y minus 6 over 8. So that is 3 over 4. So it's 3 over, oh, writing very bad. Okay, 3 over 4, I think so is correct. And this thing, like I mentioned, separate the 4 out. So it's 4 negative 2 y minus 3 over 4. Okay, x plus 2. Okay, we can get a lot of information from this. Okay, first is vertex. Okay, vertex will be, okay, since it says it's a 3 positive here. Oh, sorry, this is 2, right? My own writing cannot recognize. Positive means to count negative. Y is negative, so to count positive. So 3 over 4. Settle. Okay, to find the directrix. Wait, before I try to find the directrix, find P. So what is P? P is negative 2. So since this is y x squared, so most likely, what, and it's negative, so it's going downward. Okay, going downward. Okay, so going downward means the focus should be here, the directrix should be up. Okay, so it's negative 2, right? So what that means is, okay, directrix is up here. So up here means 3 over 4 plus 2. Okay, so directrix is y equals to 3 over 4 plus 2. How much is 3 over 4 plus 2? That is 8 plus 3. 8 plus 3 is 11. So the matrix is y equals to 11 over 4. And focus is so it's minus 2. So it's 5. Negative 5 over 4. So that will be negative 2 and negative 5 over 4. So that'll be the focus, directrix. And exhibit, since this is all happening, oh, all happening in this line, so it's and x equals to negative 2. Okay, so x equals to negative 2. That'll be the axis of symmetry. Just now I mentioned, but I'll mention it again. I'll just use abbreviations because we don't have a lot of space. AOS, axis of symmetry. Okay, just for the heck of it, I'll draw it again. Okay, so first things first, find the vertex. What is the vertex values? Negative 2 and 3 over 4. So it's something like say negative 2 is here. And say 3 over 4 is here. Okay, so somewhere here. Okay, and then it should go downward. And we know that it's the focus is on negative 5 over 4. So somewhere here. 5 over 4. Okay, and the directrix is somewhere up there. Okay, okay. And you can just sketch. Okay, rainbow, so you can just sketch. Okay, I'm not sure if this is the correct place, or for the y-intercept, if this is the correct mix. Okay, but I'm just sketching for fun to show that This is what most likely it will indicate. Okay, so this is how you generally solve these questions. Okay. What else? Okay, that's about it. Okay, level now. If you get all this information, usually this question very rare now. Okay, the only time you will see these type of questions is they ask A and B, and then they ask you to find the intersection point between these two. Okay, so you have to make it an equation and find the intersection points lah. So it's very rare to give you something so simple, but it's for the sake of our class right now. It's a bit simpler lah. Okay, so we've done how many questions so far? Okay, three. Okay. Okay, so I want to skip the sketch. Okay. How about this one? Question number 8. Okay, this is more of a real life question about parabola. This is an applied parabola. Okay, so let's go to here. Okay, let's try to take out the let's digest the information from here. Okay. Figure below depicts a bridge suspended by a cable. The shape of the cable is a parabola. If the span of the cable is 2s meters, the sag is h meters. Find the equation describing the shape of the cable in terms of s and h. Okay, so what do they want us from here? Okay, so generally it's a parabola, it's going upward. So we can say that this is the y-axis. Make it smaller, not too small. Okay, and space. Okay, so this is generally the y-axis, and this is generally the x-axis. So we can say that maybe this is a positive curve. Okay, so the p could be positive. Okay, so I can shade the shape of the cube, blah blah. Okay, okay. They give here s equals to 50 and h equals to 5. If okay, this okay, so this is a two-part question. So this is most likely something that is more likely to come up in your exam. Okay, something applied. Maybe in section A, I don't think so. Section A is more towards a direct question. Maybe this will be something in your section B. Okay, but very seldom also they ask you geometric analytical geometry this short. Usually will be maybe this will be A, and then B, and then C, and then D. I don't know. Okay, that'll be a lot here. Okay, anyhow, let's not think about that. Let's just approach the question. Okay, so the first part of the question, so the one in terms of S and H. So how do we go about that? Okay, so we can say that okay, let's see. You can write the equation. Okay, maybe you can write the equation as x squared equals to. Okay, we just set this as origin. Okay, we just set this as origin, so it's 0, 0. So we don't have to have like minus, minus, whatever it is. Okay, we don't want extra variables where they don't want us to have extra variables. So we can say that this could be also k. Okay, instead of using p, maybe we can use k. K y. Okay, k will most k equals to in this situation it equals to the 4p. Okay, k is just equal to 4p. Oh, I want to erase something else. No, no ruler, thank you. Or p to y. So okay, from this, what can we do? Since the point sh, okay, s, okay, this is a s and this is h, so I can say that any point here is like a s and h. Okay, these coordinates, okay. This s and h will be in this parabola. Will be most likely in this parabola. I can say that s squared equals to k, and I can then say k equals to what? S squared over h. Okay, this is page 1, this will be taken to. Okay, then I can say that the required formula is most likely something like x squared equals to s h over s squared over h y. Yeah, I just want to keep it simple like this. Okay, so this is our you can just actually write this as a final answer. This should be fine. You don't have to think too hard for these type of questions actually. Okay. So let's go to the second part of the question. Okay, let's say if S is equal to 50, so S equals to 50, and H equals to 5. Okay, now this is our problem here. Okay, so how we can just input these terms, take x squared equals to 50 squared. How much is 50 squared? 2,500? Is it 2,500? Yeah, 2,500. So 2,500 divided by 5, so that's 500. So x squared equals to 500 y, right? Okay, so since we say this is 5, this is 5, and we say this is 500. Oh, is this 50? Sorry, not 500, 50 is 50. Okay, so we can also say that hmm, the second part of the question is find the height of the cable at point from 1 to. So we need to find from one of the endpoints. So are they asking for the sag, or are they asking for just this? Okay, they're asking just that. So we can say mm, let's think about this once. Okay, 1 point. So they want to say find the height of the cable at a point 10 meter from one of the endpoints. So 10 meters from here. Yeah, they want us to find this. Okay, let's say this is 10. It is 10. So they want us to find this h. So if it's 10 meters from one endpoint, and we just said that s equals to 50, this is the maximum boundary. Let me say this 50. So that's 50 minus 10. 50 minus 10 is just 40. Okay. And we just want to find when 40 squared equals to, okay, just now how much? 5,050 squared over 5 is 500, right? It's 500 y. So y equals to mm, 40 square like that. 1,600 over 500 to zero solve like just 16 over 5. I think 16 over 5 is around 3.2. Is it? Okay. 16 over 5. Yeah, it's 3.2. So y is 3.2 meters. Alright. So okay, that's one of the more you're using your brain type of questions. You cannot just straightforward look at it and answer. Huh? Okay, you have to use your brain. I think about it for a while. Okay, maybe we can take a maybe 5 minute break from here. How about you guys in the break time? I'll just try to sketch these questions. I'll just take a snapshot of this question. Okay, take a snapshot now. Okay, this one. Okay, maybe not this one. This one you haven't studied yet. This one. Okay, take a snapshot of these two, and maybe we can try it after our break. Okay, hopefully you guys took the pictures. Okay, yeah, back from the break. Okay, so I hopefully you guys try to do these two sketches. Okay, not really. Okay, that's very. I think if you've gone through chapter 1 with me, that's very easy to select. So It's just y equals to 2 set x. So that just looks like you just did this, like you can just square both sides. If you square both sides, you just get y squared equals to 4x, and then this is basically parabola. Okay. Only for this chapter can you do squaring like that and do it both sides. Do not try this in chapter one questions if they ask you to sketch y equals to 2 square x. Only show the positive side. Do not show both sides. Okay. Don't do that. Bad idea. Okay, so since there's not much information, oh, it's a oh, yeah, let's go like that. Okay, done. Okay. Bx. Okay, so this one, you have to move it around. So I would say, oh wait, oh yeah, no. This chapter also you cannot do this. Really. So you have to sketch this. So I would say, let's say this, oh, let's say this is 0. Hmm. Let's say this is 0. So still look like this. Only one side. Yeah, you cannot do that regardless of what chapter it is. Yeah. Consistency, right? So it has to still be only one side. Okay, so get this. Okay, so let's try B. So B is x equals to 2 minus square root of y minus 1. So I would say you can move this around. So if you move it around, it's x x minus 2 equals to negative y minus 1. I would say you can move this around to, okay, you just square both sides. So we square both sides. We can have x minus 2 squared equals to p y minus 1. So since we know that p is 1, okay, you square the negative sign, it will just go away, right? So that's fine. That's why it's positive. And also, since it's just 1, okay, factor just 1, so it's going to be like 4, and p is going to be 1 over 4. Y minus 1. Yeah, it's just going to be like that. Okay, so that's just how generally it should look like. Okay, so how would this equation look like? Even I said don't do this, you can still use this to have a rough idea on how it will look like. Okay, so just sketch it up. So since you know it's 1 over 4, and you know it's negative 1 and also negative 2, so then the vertices is 2 and 1. Okay, 2 and 1, so 2, 1. Okay. And so it'll go like this. But since it's only taking the negative side, see here, so only negative side, so only here. So you don't need this positive side. You don't need the positive side. And since you don't need the positive side, you only need one value for this. The y-intercept, so y-intercept is gonna be equal to y equals to 0, right? So 4, negative 1, then I think it's gonna be 5. Yeah, y equals to, oh no, so x equals to 0, my bad. X equals to 0, so equals to 0, so that's 32 squared equals to 4. Sorry, 4. There's no 4 there, it's only 1, so 5 minus 1. Okay, so this is gonna give you y equals to 5. So this value is gonna be 5. Okay, so there's these two line information for this stretching of. Okay, so that's question 9.
The third line, when v square can just add 4p beside y minus 1.
Yeah, because it's just a variable, right? You then, but I have to make sure you put a value for it.
Mm, okay.
All right. Okay, so that's those done. I think I mentioned one more. What did I mention? Oh yeah, this one. Oh, 16. We have not come to this one yet. Okay, let's leave 15 alone for a while. This is an ellipse. Oh, I wanted to finish this entire chapter in maybe 2 classes. Let's see how it goes. So today, okay, maybe we can. Okay, I think that's the last question for parabola. Okay, have a go and on this one. You guys can have a try later when I send this video. Okay, find the equation of the ellipse. Yeah, okay, let's go to ellipse. Okay, so ellipse. Okay, what does ellipse look like? Okay, you can go through the notes I sent. Okay, when you go to notes, the general formula of an ellipse will look something like this. Okay, x minus a squared over k. I don't know. To you plus. It's always plus. Remember, it's always plus. Y minus b squared and h equals to 1. Okay, it's always this setup. So what do these things control? Okay, like okay, basically what do these things control here? Like okay, so A and B, like before, they control where your vertex or center is. Okay. So in this case, since a parabola for an ellipse, it looks something like this. Okay, compared to a parabola where the vertex is where it starts, right? It goes like this, right? So for an ellipse, whatever the value you get from here, whatever you get from here, that's what we call the center. Okay, there's no more. The vertex means something else now. Okay, okay. So the center is whatever you get here. So let's say this is I don't know, a is 5, so that's -5, and maybe b is I don't know 2. So -5, -2. So then the center is gonna be 5 and 2. Okay, so that's the center of the ellipse. Okay, ellipse generally they have two types. Okay, either they measure in the x coordinate or they measure in the y coordinate. It's nothing. It's just whether the potato. Okay, I like to imagine this like a potato. The potato is either going is a tall potato or is a fat potato. Okay, it's either a tall potato or fat potato. Okay, that's just how I imagine it lah. Okay, that's a fun way you can imagine this. Okay, tall or fat potatoes. Okay, so one way you can imagine it is look at how the value differs. Okay, Tarani, I think your mic is on. It's something like this. Yeah, okay, thank you. So, how to know if it's a tall or fat potato? Look at the center here. Okay, so if the center, I mean, look at the center, vertex, and focus, the values they're given here. So if it's a consistent value is on y, so meaning that the vertex, the focus, everything's on the same plane. Okay, when everything's on the same plane, it's gonna, okay, what do you think?
ரூம்ல புது டூத் பிரஷ் இருக்கா? நேத்து
Is
என்னோட
it gonna,
டூத் பிரஷ் எடுத்து சிங்க்ல தேய்ச்சிட்டேன்.
is it gonna be like this or is it gonna be like this? I think it's gonna be a fat potato. Okay, why a fat potato? Only if it's like this will we have all of them in the same y coordinate. Okay, so if let's say all of this are only the x coordinate changes, then it'll be tall potato because x is constant. Okay, you guys won't learn. Okay, in your syllabus there is the you won't learn this, but this is just maybe I can just go slight tangent. Just stop it. Okay, so that's how like I mentioned just now. That's how you find out whether if it's the minor or major axis is x or y. Okay, you just look at the values given. Okay, if the vertices are on the same plane, whatever the same. So sorry, give me 1 second. Okay, let's look at this question. Okay, this one you don't have to sketch it, so that's good. Okay, so but we still have to find the equation. Okay, now like I mentioned just now, what does these two? Okay, these A and B are what you find for your center. Okay, what about the K and H? K and H is what actually controls the radius. Okay, the radius of the ellipses. Okay, so it will actually be square K squared and H squared, because okay, let's say your value is K is gonna be 9, so your radius is actually gonna be K. Your radius is gonna be K for the x coordinate. So it's gonna be 3. Okay, your radius is gonna be 3. And let's say this is I don't know, 16. Let's say H squared is 16. So H is gonna be 4. If H is 4, this distance is gonna be 4. Okay, that's how we find the radius. Okay, in simple, this is the simplest way I can explain it. So in this case, since h is more than k, h is more than k, sorry, h square more than k, same lah. Okay, doesn't matter. H is more than k, the h square confirm more than k. This is the major. Okay, this is the minor. Okay, major. I'll use capital M for major, and this will be minor axis. Okay, so this will look like a semi-tall potato. Okay, look, go up more. Lah. So that's enough of potatoes. Let's start drawing. Okay, since we know all of these are the same plane, the same y coordinate, so I can say for certain I can do something like this. Okay, so I know the center is at 0, 0, so let's draw that 0, 0, right? 0, 0. That's x and that's y. So this is my center, and then my focus is on 2, 0. Okay, so what is the focus? Okay, I'll tell you guys how to find a focus later on this. Actually, it's in the notes. Okay, where did I put it? Focus is basically a square for a square minus b square. Okay, okay, my notes and what I wrote here might be different. Okay, in here I wrote k and h, right? So it's like this basically. Okay, okay, so the focus is usually is k square minus f square equals to k square minus 6 square. Okay, like this. Okay, this is the general formula to find the focus. Okay, so you always major minus minor, by the way, major minus minor. Okay, this is another thing you have to remember for this chapter. These formulas will not be given, so always remember that. Okay, so next one is a 2, right? So this is 2. And finally, the vertex. Okay, this is where it touches. Lah. Okay, so this is a 4. Okay, so we can say that A is the. Okay, so this whole distance. Okay, this whole distance is how much? 4. Okay, so say my k equals to 4. Okay, and I know that just now I said that C, the focus, right? Focus is 2. Okay, 2, so that's going to be 4. Okay, so this is how we find H. Okay, so 2, so 2 squared equals to, I since we know that this plane is going on horizontal, we can actually say that the major axis lies horizontally. Okay, we can say that the major axis lies horizontally. Okay, you can say that 4 square, so 4 square is 16 minus h. Okay, so that's 4 equals to 16 minus h, so theta theta, so that's 12. So h is h squared. H squared equals to 12. So h equals to okay 4 4 3, right? So that's 2 set 3. 2 set 3. Okay, so that is the length here. Oh, length here. It will be 2 3. So if I were to sketch this, can you see yellow? It's nice. Okay. I want to sketch this potato. It'll look like this. It'll look like this. Okay, 2 3. This distance also, uh, 2 3, and this distance will be 4. Okay. Okay, so let's go back to the equation. Since I know all of them start at origin, so y also seems like to start at origin. So there's no b, a and b here equal to 0 basically. So just take the k value and then h value. Okay, since it's all squared, so you just have to put the square values here. So 16 and 12. Okay, since just now I mentioned that the x is the major, so k is going to be equal to 16 and h is going to be equal to 12. So it's going to look like x squared over 16 plus, always plus. Ellipse is always plus. Y squared over 12 equals to 1. Okay, so this is our equation. Okay, okay. So I'll just quick run through the second question. Okay, same here. So this one, the center is on 2 -1, I believe. Then the focus is on 2 3, and then the vertex is on 2 6. Right? So I can say that the major axis lies vertically. Okay, it goes like this, right? The major axis lies vertically. Okay, so what's the first detail I need to take out? Okay, center points. Okay, center points. 2 and 1. So that's gonna be x. Okay, net positive becomes negative, so minus 2 plus, don't forget the square, plus y. Positive is equal to negative, so negative becomes positive, minus positive 1 square over. Okay, so now let's look at this total distance. Okay, so from center to vertex, that's -1 to 6. So that's total of 7. Am I right? That's total of 7. And from the focus to center, that is a total of 4. Am I right? Yeah, so that's a total of 6, 7, and 4. So let's use the formula. F squared equals to a squared minus b squared. Just make sure that a is more than b, then you should be good always. That is a square, right? So you have to only have a positive number. Okay, f, how much is f? That is, total is 4, so 4 is 16. How much is this? This is 7. 7 is going to be 49 minus b squared. So it's going to be b squared equals to 49 minus 16. Can someone theta this on their calculator? 49 minus 16. I think you get 33. So b equals to square root of 33. Can someone also theta that in their calculator? Yeah, I'll theta it myself. Okay, so around, I think you just put, leave it as square root 33. Okay, just leave it as square root 33. Okay, so this, how will this potato look like? It'll be a tall potato as well. So just to give you guys an idea. That's why I'm sketching this, but you don't actually have to sketch. Oh, okay, since I know that this is upper 2 6. Okay, the center is at 2 and 1, so 2 and -1. So 2 -1 here, somewhere here. 2 -1. So the major axis goes about how much again? 7. So let's leave it around here. So it's like 7 right? So 6. And square root of 33, I think this is like around 5 plus, around 5. Yeah. So what is the center? 2. So it's going to be like, I don't know, 2 minus square root 33, and also here around like 2 plus 33. And here is around 7. Also negative 1 means negative 8. Okay. So it's going to be, you can change color, can get yellow. It's going to be like, white. Okay, the ellipse. Okay, my drawing is extremely bad, but this is the center. The foci are here. Okay. So since it's a 3, right? Difference is a 4. Sorry, difference 4, right? So 1, so it's the here, and negative 1 or 4 is gonna be like around here. So it's gonna be negative 5. Right. Okay, so you do not have to label the you oh wait, you it's better to label, yeah, it's better to label. So it's since 2, so it's gonna be 2 3 means already given. Another one is gonna be 2 5. So F1 F2 like this, F1 F2. Okay. So what is the function of focus? The focus is basically says that the distance lah. Okay. The distance from okay. Okay, let's say if I take like this point to this point, it's always gonna be equal. Okay, that's the definition of focus. Okay. If I take from focus to line and focus to line, they're just gonna equal to each other. Okay, that's the definition of focus inside an ellipse. Okay, it's inside the notes. I've already mentioned the notes. Yeah, it's already mentioned the notes. Okay, so that's the first part of the ellipse for you guys. Okay, let's see then a better question for ellipse. Okay, foci at 5 1, 95 1. Okay, so from this itself, you already know that 5 and negative 5. So it's gonna be atas sini, bawah sini. So you already know it's here, and the major axis is 16. Okay, major axis is 16. So it's gonna be like this. So it's gonna be like this somehow. Okay, and since you know major length is 16, so this is gonna be 8, right? It's gonna be 8. So since I know this is 8 at 8, and this is 5, so you can just use the formula f squared equals to apa a squared minus the b squared or k squared minus, doesn't matter whatever alphabet you like to use, as long as a is smaller than b. So since I know this is 8, and remember you have to you can just use 8 honestly, since they already gave 8. Yeah, you can just use 8. Is there a faster solution for this? Let me think. Oh, wait. Hey, what am I doing? 5 x coordinate, x coordinate. Hello, my bad. It's not like this. Look at that. Ooh, sorry. There you go. This is in the x coordinate, so it's like gonna be like this. And like this gonna be a fat potato. All right, it's gonna be like that. Okay, let's see. There's a easy way to find out. You can actually find the focus center quite easily. You can just do this. Okay, just same like finding a midpoint. Okay, since the distance from here to here is gonna be the same distance. So you can just do this. I mean, you already know it's gonna be 0 lah. Okay, so you can always just do 0 0. You don't have to show the working. But if you do want to show the working, let's say the more complicated number, okay, Then I just want to show you this. Then you just do like 5 x1, you just do x1 plus x2 divided by 2. Okay, bracket y1 is equal to divided by 2. This is like form 4 stuff lah, form 5 stuff. Okay, so the 5 plus minus 5 to 0 minus 0 over 2 is 0, 0. But you look at the answer itself, you already know it's 0, 0. Okay, same thing. Same thing. You already know the center. Okay. What else do we need to know? Okay. Length. So we know the length A is 8. So we know since A is 8, we know that F, A, and B, right? So how much is F squared? F squared is, since F is 5, so we can do 25 equals to 8. 8 squared is 64, and minus B squared. So B squared equals to, how much is 64 minus
39.
39? Oh yeah, 39. So 39, so B equals to something around 5 point something lah, but I think we just use square root 39. There's no perfect number. It's square root 39. That should be okay now. Okay, so we know it's square root of 39, so it's gonna for just illustration purposes, I can just show how it will look like. I would like my space back. Thank you. Okay. Wait a minute. The center just now was 0, 0, so it's gonna be easy for you to draw. Let's start from here. This will be a center. 5, right? 5, 8, and I just 8. Okay, so that's that. And then this will be what? Square root 39 5 something left. It will be negative square root 39. Okay. So it looks something like changing it back to yellow. This looks like it's a very ugly potato even for my standard. Okay lah, boleh lah. Okay. So yeah. So this is how it look like. Your final equation will look final equation will be this x squared over 64 minus y squared over 39 equals to 1. Okay. That's about it. Okay, so until now, okay, today we have covered on the basics of parabolas and also basics of ellipses. I'm going a bit slow today because this is still considered a new topic for you guys. Uh, so I'll still go a bit slow when we go for hyperbola later and also circle. I'll do circle and what do you call it? Hyperbola on the next class. Okay, so it's around 10:47. I would like to extend this class actually, but unfortunately, I have a few events I have to take care of. Actually, it's supposed to be set. This was supposed to be set yesterday, right? But due to request, we set it today, and it actually clashed last, so I had to run today a bit faster. If not, I will actually extend the class. Okay. I'll send this PDF later and also the recordings all I'll be set up later. For now, I cannot really do that right now. I have to go out immediately after this. You guys can try. Okay, later I'll send you guys the questions. You try question 14. Okay, that's mark. Question 14. Question 15. Let's see. Question 17. Okay. Okay. That's all. Let me see. I have some extra questions here. Okay, no. Okay, no need. Okay, no need. Oh yeah, you can try this. Okay, try question 16. Try question 16. 14. Oh, oops, sorry. So try question 14, 15, 16. Don't worry. Just rest for now. I know you guys are busy with your coursework and also your, what do you call it, your physics and chemistry and your bio experiments. So take a good rest today. I'll upload this maybe later in the evening or before that. Okay. Okay. So I think we'll end class today. Oh yeah, before okay, maybe Shavina can leave, but this is something just want to mention to Taranila since you missed like a few minutes of class. Okay. But I end the recording now. Okay, thank you guys for
Thank
coming.
you.
Okay, all right.